Assalamualaikum and hi to everyone. Today we are from Group 7 would like to present about design, fabricate and testing composite material plates. This is our group member. For the introduction, composite materials are made by combining two or more DC materials with different physical or chemical properties. Typically, it consists of fibrous reinforcement and a matrix. And for the application of composite material is in aerospace. For the improved fuel efficiency and for the automotive, it contributes to lighter vehicle. And for the construction, it used for corrosion resistant. And for the marine and chemical processes, is ideal for harsh and corrosive environment. And the advantage of this is combined high strength and stiffness with low weight, resistance to heat, corrosion, and harsh condition. And the challenge is that it is a high cost and environmental degradation. And for the yield strength is the stress level at which a material shift from elastic deformation, where it can return to its original shapes to plastic deformation, resulting in permanent shape change.
Assalamualaikum. My name is Abdul Muiz Fahmi. Now I will present about methodology. For our project, we use three material: plastic uller, aluminium foil, and A4 paper. For the plastic uller are clean, cut into uniform straight and smooth to ensure consistency and avoid stress points. Second point is stripe are bonded with adhesives aligned carefully and compressed to create a strong uniform composite. And lastly is the correct composite is inspected and tested for tensile strength and elasticity to assess its performance. For the aluminium foil material is aluminium foil sheet are inspected for flaws cut into uniform strip 20 mm times 200 mm and smooth to ensure consistency and avoid stress point. For the testing is the composite is inspected for accurately, tested for tensile strength and elasticity using a universal testing machine, and evaluate for structure performance. Next material is A4 paper. A4 paper sheets are inspected for flaws cut into uniform straight 20 mm times 200 mm and smooth to ensure consistency and prevent structure weakness. Three strips are bonded with adhesives carefully aligned compressed to eliminate air gaps. And lastly is the composite is inspected for accurately tested for tensile strength and elasticity using a universal testing machine. And lastly is epoxy glue. Epoxy designs are valued for their higher mechanical strength, UV resistant, corrosion resistant, and compatibility with reinforcing fibers like glass, carbon, and aramid. And last point is why offering low order compared to polyester designs, epoxy require careful handling due to their caustic nature, higher viscosity, and the need for a high temperature process to achieve optimal performance. Next for the methodology is tensile strength test. The material is stretched in a controlled environment and elongation is measured with result plot on a stress strain diagram. Second point is the test provide important metrics like yield strength, ultimate tensile strength, and elongation at break, which assess the material strength and ductility. And this is our formula to calculate our data.
Hello, my name is Zaki Irfan, and now I will present about the result and analysis of our data. And before I start explaining about the calculation of our result, I want to show the brief, simple flowchart. So the first step is to actually obtain data from the lab testing. So from the lab testing, we will do tensile strength test, and the main purpose is to determine the Young's modulus to find the stress and find the strain. And from the lab testing, we will also get many types of values or data, and I will explain furthermore when it comes to the calculation. And next, after we get the data, we can start to do calculation, and then basically before we start doing our calculation, we need to change into SI units, especially when we know that Newton is the unit for Newton is kilogram over meter square, and there are certain units. Eh, uh, yes, there are certain units that needs to be changed from the data that we obtain, such as millimeter. We need to change the millimeter into meter square, millimeter square to meter square. We also need to change kilonewton into newton. And then after that, we can find the stress and the strain based on the formula that we learned in chapter 1 and chapter 2, if I'm not mistaken. And then after that, we will find the Young's modulus based on creating the graph. And for the creation of the graph, we will use Microsoft Excel because it is probably the best software to use. So now you can see is for the data for stress and strain, we put this data into Microsoft Excel because one of the reasons is we can use the formula in Microsoft Excel to change units, and then we can also use Microsoft Excel to create the graph for strain and stress, and then we also wanted to find the Young's modulus. So here, the elongation is in millimeter, and then the load is in kilonewton. And with both value of elongation and load, we can find the normal stress and also the strain. And it is given on the left that sigma equals to P over A, which is P is load, and then A is the area for our composite material, cross sectional area. And then for the strain is called epsilon, is the elongation divided by length of our composite material. Um, However, we needed to change the units first, where here the strain is, we don't need to change the unit for strain because strain is elongation divided by length, and when millimeter is divided by millimeter, it becomes neutral. It means that strain has no units. And even if I change the unit into meter, uh, which is like elongation in meter and then length in meter, it would not change the data because um, uh, there is no unit. So it's the same. But however, when it comes to the stress, it is very important to change the unit, such as the load, which is in kilonewton. We needed to change it into newton. And then also for the length in millimeters, not length, sorry, the area is in millimeters square, and we needed to change it into meter square. So yes, we use Microsoft Excel formula command in order to get all of the values, because if we do manual calculation, I think it's possible, but it will take a lot of time. And because of that, we should be grateful for this type of software in civil engineering because it really saves us time, and it also means that we can do complex calculation in just a short amount of period of time. So now you can see the table of an example of calculation, and this is actually for sample 1. Um, I wanted to explain about the specification, which is the length, the width, and the thickness is basically decided by our group. For the length is to be 150, and then the width based on our project must be 20 millimeter, and the thickness must also be lower or equals to 2 millimeter. For the length, I'm pretty sure it needs to be shorter than 200 millimeter. And then there are also the data of maximum extension and also maximum load. We will use the value of maximum load to determine the tensile strength, and this is an example of how we calculate the tensile strength. We decided to calculate tensile strength in the unit of gigapascal, which means the unit is 1 times 10 to the power of 9 is for giga. So the maximum load is in kilonewton, and we needed to multiply it by 1,000 in order to to eliminate the kilo. And also, if you notice, for the SI unit, the cross sectional area is in meter square, so we needed to also cut out millimeter square, and we multiply it by 1,000 to the power of 2 because it is millimeter square. It also means that the 1,000 is also square, is also to the power of 2. And then we will get the tensile strength of 0.039978 GPa. Now this is just for one sample. We have a total of three sample overall, and we needed to create three different types of table based on three different types of sample. Last but not least, this is the mm, graph for stress and strain, and based on the graph we will find the modulus of elasticity, and I will explain how do we get this graph. So basically, from the data that we have earlier is the value of elongation and load. We can determine the stress and strain also by using the specification measurements for our composite, which is cross sectional area and also length, in order to get the value of stress and strain, as I explained earlier using the formula. And now from the Microsoft Excel, we just put the value of stress and strain, and then we will create a graph, which is a stress and strain graph. So the strain is in x-axis. If you notice, the unit for strain is millimeter over millimeter, but basically it has no unit. Um, and then for the unit for stress is gigapascal. So it means that 1 pascal is Newton per meter square. We get 1 pascal, and then for gigapascal means that we need to divide it by 1 to the power of 9. And then we will get the graph. And this is basically an example for sample 3, like I told you before previously. We needed to calculate based on three different samples. So three different samples will have three different types of graph. They may look similar, and they also have different types of values of modulus elasticity, but they might be similar to each other based on our composite materials because we use the same materials. So after we create the stress strain graph, as you can see, when we learn in mechanics of material in chapter 1, um, we understand that to get the Young's modulus is from the graph stress versus strain, where we needed to see the region where the graph is imagined in a straight line. And here you can see on the left graph, the red arrow is showing that there is a line which is almostly straight, and we can imagine that as the to determine the Young's modulus. So using Excel, we don't instantly create uh, a line which I forgot what his name. I will pause right quick to find his name. So the name in Microsoft Excel to create an imaginary line is called trend line linear equation, which is shown on the right side. And basically, we took all of the data from the red arrow, starting from upper boundary to lower boundary, and then we will get um, the stress strain graph, but it is until proportional limit for our sample. It means that it only shows that region, that specific region where we assume that it is almost a straight line. And then from the line, we take the value where it is accurate to the imaginary trend line, so we can like completely assume that it is straight. And then we get two different types of coordinate, which is the upper boundary is um, identified as rise and the lower boundary is identified as run. And using the modulus of elasticity in gigapascal, we just put the coordinate value and we will get the Young's modulus in gigapascal. I want to explain a little bit about Microsoft Excel. When it comes to linear equation, we can see that y equals to 3.5859x also means that Young's modulus is around the value of x. So our value is 3.59. The x value is 3.58. So it is close. And then the r square is equal to 0.0051. Is it means that the closer the number to digit 1 means that the more accurate, or uh, the more accurate it is as a straight line. So if we get the value of 0.5 or 0.2 for r square, it means that our graph is wrong. It is incorrect because it will not it is not identified as an imaginary straight line. So that is it for the result analysis. There are three samples, but in this slide, I will only show one example, because if I show all of the calculation and all the result, it will be too long. However, all of the details and will will be shown in in our report.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muafi bin Azmi. So we move to discussion part. Tensile strength result. Number one, sample one had the lowest tensile strength of 0.0298849 GPa, likely due to weaker bonding or interaction between materials. Okay, number two, sample 2 had the highest tensile strength of 0.09978 gigapascal, making it the most capable for bearing loads due to its optimal material arrangement and bonding. Number 3, sample 3 showed moderate tensile strength at 0.033121 gigapascal, suitable for application requiring a balance between strength and flexibility. So next, modulus of elasticity result. Number one, sample with the lowest modulus of 3.197180 gigapascal is better suited for low mechanical demand application. Number two, sample 2 had the highest stiffness with a modulus of elasticity of 4.081198 gigapascal, making it ideal for rigid application like beams or structural reinforcement. Okay, number three, sample 3 had a moderate modulus of 3.599844.08 gigapascal uh, of more flexibility for energy absorbing application like shock absorber or hangers. Okay, next, stress strain behavior. First, all samples followed Hooke's law up to their proportional limits as seen in the linear regions of the stress strain graph. Second, beyond the proportional limit, sample 3 exhibited the greatest elongation before failure, indicating the highest ductility and flexibility. So, last but not least, key insight for this part. Number one, the composition and arrangement of layers are crucial for mechanical properties. Step 2 is ideal for high strength, low deformation application. Step 3 is suited for flexible, impact resistant users, and step 1 cost effective for low demand application. Second, effective bonding and selective material with complementary properties enhance performance. Iterative design and testing are essential to optimize composite materials for specific mechanical requirements. Okay, that's all from me.
Assalamualaikum. My name is Muhammad Naim bin Zulkifli. Today, I want to introduce about the conclusion. This project gave us useful insight into the mechanical properties of composite material made from aluminium foil, A4 paper, and plastic roller. So, the average peak tensile force is 0.10294 GPa, and the average modulus of elasticity, which came out to be 6.8315 GPa, was far below the target of 10 GPa. This clearly shows that the material we choose weren't suitable for achieve the sharpness and strength we aim for. The result also reveals some challenge like consistent in how to material we prepare and arrange, as well as possible error during testing. So it became clear thought that better material selection, preparation method, and testing process and need to create stronger and more reliable composite. While the project fell short of expectation, it laid the groundwork for future research and highlighted the obstacle overcome when using recycled material to make high performance composite. So that's all from me. Thank you.